Hi friends, good morning. In the last session, we have explored the concepts in IO package, how to get keyboard input values, how to get the character inputs, string inputs, conversion from the strings into the equivalent integers, the float, double data types. We have seen those things. In this session, we focus on type conversion and costing in Java. Java is to be a strictly typed language. We have already discussed. Because of Java is a strictly typed language, we cannot make an assignment statement like this. Int x is equal to 25 or 24.45. This results in a compile time error because the right hand side value 24.45 by default, this is a double quantity. Double quantity cannot be assigned to the left hand side integer variable. This results in the compile time error. Understand? Because by default, the floating point quantity in Java results to double type. A double takes a higher precision. This is a higher type. Higher data type value cannot be assigned to the left hand side lower data type. X cannot fit the actual value of double value. This results in error. So you need to carefully check, right? If the types are actually compatible. In C++, right, there is no problem. You can assign a floating point quantity to the integer variable. The fractional part will be lost. Only the integer portion is assigned to the left-hand side integer variable. That is valid in C++. Where in Java, though the floating point and integer are compatible data types, right? There is no doubt in that. Floating point and integer are compatible data types, numeric types. But if here in the left hand side, integer data type is there, but in the right hand side expression, higher data type is there. Higher data type value cannot be fitting the lower data type. This is not possible. This stage, compiler reports the error message. Java automatically performs automatic type conversions if the two types are compatible. For example, a float and integer. These two are compatible types. In case if you write a float f is equal to 1.2345, that is perfectly valid, or 12345. In this case, what happens? 12345, this is taken as the integer variable, right? Integer value. The integer value 12345 is directly assigned to the left hand side variable of float. This is perfectly valid. In this case, f assigns 12345 dot 0. This is the implicit assignment to be made to assign to the left hand side variable here. Now let us check, right, how the lower data type values are actually assigned to the higher data types, and how the higher data type expressions are evaluated and assigned to the left hand side lower data type. That is a concept of type conversion and costing. Have a look into this method. Static public void main string arguments, right? In this method, I have declared some variables. Byte b is equal to 1. B is a byte variable and it is initialized to 1. S is a short variable initialized to 2. I is an integer variable initialized to 3. And L is a long variable initialized to 25. Long L is equal to 25. You can also write long L is equal to 25 capital L or small l to actually have 25 as the long literal. A float f is equal to 1.2 f, double d is equal to 25.0, redundant d or capital D, small d or capital D is not necessary. Character ch is equal to x is one character variable. Then boolean bn is equal to true. Bn is a boolean variable which is set to true. Now let us try to convert from these data types into some higher data types. What is byte? Byte occupies 1 byte. What is short? Short occupies 2 bytes. We are trying to assign a value s is equal to b. S is equal to b. In this case, what happens? B is a lower data type, and what is S? S is the higher data type. So B is 1. The value rate 1 as a byte value can easily be fit into the short variable S. So byte to short, this conversion is valid. Then I is equal to S. What is I? I is an integer variable. S is a short variable. Short to int conversion is valid. Then L is equal to I. L is a long integer variable, long variable simply. I is an integer variable. Integer to long conversion is valid. Then F is equal to I means F is a floating point variable. I is the integer variable. Integer variable can be assigned to the floating point variable. This is a valid conversion. Next, D is equal to I means D is a double variable. I is an integer variable. Integer can be assigned to the left hand side higher data type, double type. So into to double conversion is valid. Then D is equal to L means D is a double and L is a long variable. Double takes more precision, 8 bytes, 64 bits. Long byte short int 1248. So 8 bytes. However, a double is a double precision quantity. So long variable can be assigned to the double variable. Long variable, long value expression can be evaluated and assigned to the double variable. This is valid. Then D is equal to F. Now what happens? F is a floating point quantity and D is a double quantity. Is D is equal to F valid statement?
Yes, sir.
Can you assign a floating point quantity to a double variable?
Yes, sir.
Is this true or not?
Possible, sir.
Possible, sir.
Say yes or no.
Yes, sir.
Are you all there? Assigning
Yes,
a
sir.
floating point to a double variable. Is this a valid
Yes.
assignment statement?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Please interact with me. Whatever is right or wrong.
Yes, sir.
Anyone, please? Okay, your message, most of you, yes. This is perfectly valid. Y means F is a floating point quantity. Uh, uh, Byte short int long, a float double. Float a single precision quantity, double takes double precision quantity. Float which is equivalent to 4 bytes similar to the width of int 1 to 4 byte 1 short to int 4. So same 4 bytes. What is the width of float?
4.
What is the width of a floating point variable?
4.
It's
4.
4 bytes. Are you sure?
Yes, sir.
Very good. A float occupies, right, 4 bytes. What about a double? A double occupies 8 bytes. So, float quantity can be assigned to the left hand side higher data type double, that is valid. D is equal to F. A float to double conversion is valid 1. Now, coming to this one, I is equal to CH. What is I? I is an integer variable. What is CH? CH is a character variable. CH is equal to X, small x. Now, character to int conversion. What about this conversion? Characters are processed using the equivalent integer value, ASCII value. So the ASCII value of ch, small x, is assigned to the left hand side integer variable. Character to int conversion is valid. Likewise, character to long, character to float, character to double. All these conversions are valid one. Now let us run the code. Java C type conversion 1.java. Java type conversion 1. The code results in this output. Byte to short conversion is valid. Short to int, int to long, int to float, int to double, long to double, then float to double, character to int, long, float and double. Right. So what are these? These are said to be the compatible data types. In case of these compatible data types, automatic conversions are supported in Java if the two types are compatible, and the important condition is left hand side data type should have the higher data type than the right hand side expression. So with the right hand side expression, this is to be the source type, and the left hand side type is to be the destination type. If the destination type is greater than the source type, and if the uh, data types are compatible, then automatic type conversions are possible. Having any queries in this program? Java's automatic type conversions are going to be taken place if and only if the two types are compatible, source type and destination type. Second one, the destination type that should be greater than the source type. Otherwise, compile time error is a result. We need to perform a proper casting operation if it is required to avoid the compile time error. If you have any queries in this, you can ask. So coming to the automatic type conversion rules. Java's automatic type conversions are taken place if and only if the two types are compatible. That you can say one is a source type and another one is a destination type. Source type is going to be placed in the right hand side, and destination type is the data type which is defined in the left hand side variable, LHS variable. Source type is right hand side expression. This is the first rule, necessary condition. The two types are compatible. For example, numeric types, integer, float, character, long, double, like that, as we have seen in the previous example. Second one, the destination type that should be larger than the source type, then only the source type value is evaluated and which is fit into or assigned into the left hand side variable. So in the previous example, we have seen several conversions. Leaves the data type. Byte is converted into short, int, long, float, double. Then short is converted into type promoter to int, long, float, double types. And integer can be promoted to long, float, double values. Then long can also be promoted to double type that you need to check. Then a float can also be type promoted to double type. So byte short into float, right? These are, for example, the source types. These are the corresponding destination types. So when the left hand side is a higher data type, LH is higher data type.
Sir, what about string data type, sir?
Hand side expression results in the lower data type. The corresponding conversion is said to be a widening conversion. Understand or not? In a widening conversion, right hand side expression that results in a lower data type. Left hand side expression should be the higher data type. Then the least data type value is assigned to the higher data type value. This is a widening conversion. Now try to look into this example, type conversion to having these initialization. Byte b is equal to 1, short s is 2, int I is 3, long l is 4, float f is 1.5, f and double d is say 3.14159, the value of 5. And considering these initialization, character ch is equal to y, boolean b is equal to 2. Now have a look into the statement. Ch is equal to b. What is ch? Ch is a character data type. What is b? B is a byte quantity. Byte to char. What about the conversion? Is this a valid conversion? Say yes or no.
Sir.
Unmute yourself and interact with me.
Sir, sir. Hello, sir. Excuse me, sir.
And you assign a byte value to a character variable. Is this a valid conversion? Yes, sir, it's valid. How? One of you mentioned Boolean and byte are represented by the same variable. Boolean b byte b. Okay, let me change. For example, Boolean bl. One compile time error is eliminated. Very good. Then ch is equal to b. B is a byte one, but ch is a character one. Character and byte are incompatible data types, right? Character and byte are incompatible data types. Likewise, short and character, here int assigning the integer value to a character directly, this is not supported. Ch is equal to L, right? Assigning a long value to a character, assigning a floating point value to the character, likewise assigning a double value to the left hand side character variable. These are incompatible data types. So you have to make a note on character to the right hand side, byte, short, int, long, float, double, or even Boolean. These are incompatible data types. In the sense that, right, don't confuse character and integer or character long float here. Since here I mean character variable is equal to right hand side expression, which involves these things. We cannot directly assign these things. For example, integer long to the left hand side character variable. So in this case, we can have the incompatibility between the source type and the destination type. Likewise, the character and the Boolean, right, are also said to be incompatible data types. Character and Boolean are completely incompatible data types. We cannot assign a character quantity to a Boolean variable. For example, character ch, already we have written ch is equal to bl. This results in error. Likewise, bl, a Boolean variable, cannot assign a character expression. This results in compile time error. So just make a note on these things. The left hand side is a character variable, and the right hand side which involves byte, short, int, long, float, double, boolean, that results in a compile time error. Now let us check the code. Java C type conversion to.java. Have a look into these errors. How many errors are there? 6 errors. You try to check the number of LOC, right? Lines of code. 1, 2, 3, 4, 5, 6. The error P and BL, right, are already eliminated. We have changed the variable. So 6 errors are there. Read any one error, right? First one. Incompatible types, possible lossy conversion from byte to char. You cannot convert, right? If you convert from byte to the character one, it represents some lossy information, right? That cannot be done. So likewise here, double to char, float to char, long to char, into to char, short to char. This results in the compile time error. During the compilation stage itself, the errors are reported. So left hand side, which involves the character type or even Boolean type instead of character ch. Here you can also support assign a Boolean variable. So placing a Boolean variable in the left hand side, character variable or a Boolean variable. In this case, right hand side is a byte, short, int, long, float, double, other than Boolean. This results in incompatible types. So character and Boolean are also incompatible data types. We cannot assign from Boolean to character and character to Boolean. And from these fundamental types, byte, short, int, long, float, double, available in the right hand side. Left hand side should not be a character or a Boolean. Hope you understand. So how to resolve these issues when there is a compatibility between the right hand side to the left hand side? How to resolve these issues? That is our basic question. For that, what we have to do means we need to perform the type casting operation. Before going to see type casting, let us explore the further rules on automatic type conversion. We have discussed Java's automatic type conversion is taken place if and only if Condition number 1, the two types are compatible. Condition number 2, the destination type is larger than the source type. This is said to be a widening conversion. Other than these, Java also supports assigning literal integer constants into byte short long character variables. Float double variables, left hand side assignments are also valid in Java. This is another one in widening conversion rule. Already we have discussed the two types are compatible, one left hand side and the right hand side. Second, the destination type is larger than the source type. Then the extended rule is this one. Literal integer constants available in the right hand side can directly be assigned to the left hand side variable. Left hand side variable can be of byte, short, long, character, float, double. Y means literal integer constants are compatible with corresponding numeric types, say byte, short, long, char, float, and double. To explore this further, have a look into this statement. Byte b is equal to 0101. We are trying to convert from literal binary constant to a byte variable. What is 0101? 0101 is the
Binary number.
integer constant. We have already the different integer constants, say hexadecimal constant, decimal constant, binary constant, then octal constant, like that we have seen. So byte 0101, what is this? This is a binary integer constant, right? This can be assigned to the left hand side byte variable. Byte b is equal to 0101. Short s is equal to 0x123. 0x123 is the hexadecimal integer constant because this is preceded by a character 0x. In this case, hexadecimal integer constant can be supported to or assigned to the short variable. Previously, 0101. What is the name of the constant? Are you all following me?
Binary.
Binary.
Binary constant.
I want to ask a question. What is 0101 here? Make it fast. I have to cover more programs. Binary constant other than yes, sir. Okay, yeah, speak with me. I am hearing you, no problem. 0101 is
Binary constant.
Binary constant, sir.
no.
Octal. Octal constant.
Octal, sorry.
Yeah,
Octal.
I said initially binary constant, but none of you are right as said, sir, this is not a binary constant. This is clearly the octal integer constant, right? So I tested you, binary constant means it should be preceded by 0b. So this is literal octal constant to the equivalent byte value. So perfectly valid assignment statement. 0101 is converted into the decimal code, right? Further assigned to the left hand side variable. So 1 into 8 power 0 plus 0 into 8 power 1 plus 1 into 8 power 2. So 64. 64 plus 1 into 8 power 0, 1. 64 plus 1, 65 is assigned to the left hand side variable b. Likewise, here 0x clearly signifies the hexadecimal integer constant can be converted into the short variable, that is value. Long L is equal to capital A, right? Capital A is a character variable, can be assigned to the long variable, perfectly valid. CH is equal to 97. 97 is here literal integer constant. the integer constant 97 is assigned to the left-hand side variable ch, perfectly valid. So equivalent character is taken, right? The small a is at 97. Small a is assigned to ch. Then float f is equal to capital Z. ASCII value of capital F is taken and it is assigned to the left hand side variable. Floating point variable f, so point 0 will be printed. Double D is equal to A. ASCII value is taken as what is ASCII value of A?
97.
97.
97.
97 is stored in a form of 97.0. It looks 97.0 in your output, but actually storage value of D is a double quantity, 97.0. Let us test this code. Java 6 type conversion 3.java. Java type conversion 3. So first one we have the value 65. Second one, you try to convert this into the decimal code, then you will find out that a 291 decimal or a ternary system 291. Then long L A, long L A is 65, CH is equal to small a, F is equal to Z. F takes a value 90, 65 to 90, capital A to Z, 65 to 90, capital A to Z. Double D 97.0. So in a widening conversion, you have to understand the important rules. Java support automatic type conversions if and only if. Condition number A, the two types are compatible. Condition number B, the destination type is larger than the source type. And at the same time, this kind of literal constants, literal integer constants, say literal lactal, literal binary, literal hexa, literal character, literal integer, these constants, literal char, right? These literal constants are assigned to these compatible data types by short, long, char, float, and double. This is a widening conversion. Next, we see the reverse, right? When a higher value is assigned to the left-hand side lower data type, and assuming that the types are compatible, how the conversion is going to be taken place. In that stage, what we have to do is we need to perform the reverse task of this automatic conversion, widening conversion, right? Reverse task, that is it to be a narrowing conversion. See the next example. Casting incompatible data types. Suppose the right hand side is integer 1, left hand side is a byte 1. For example, here byte b into d is equal to 25. Assigning d is equal to 25. Now what happens? b is 25. 25 is of an integer variable, or simply use b is equal to b. What is b? D is of an integer quantity. Value is 25. Even though the range of byte is from minus 128 to plus 127, 25 lies in that range. But since D is of integer quantity, integer value cannot be assigned into the least or say the least data type, say byte 1. In that case, what we have to do is to avoid the compile time error, we need to perform typecasting. Typecasting you might have seen in C++ and C languages. Same format. Here you need to specify the type, then you have to use the value or use this general form type, then specify the expression. If you want, we can include the complete expression in the parentheses, opening and closing parentheses. You might have seen C language supports one type, C++ supports two types, type within parentheses, then value within parentheses, or type of value within the parentheses. In Java, Type should be enclosed within parentheses. Then you need to specify the required value or the required expression. This is one kind of type casting, right? Another kind of type casting which comes with respect to truncation and type casting. First, let us explore this one, type casting. So it's same here, byte b into d is equal to 25, b is equal to d. This results in error. The lemons I write like this. B is equal to D. This results in error. So how to write it? B is equal to byte of D. You should be very careful. D is an integer type. Integer value cannot be assigned directly to a byte variable. In that stage, the right hand side expression, since D is a byte 1, so D is the integer 1, the integer 25 should be typecasted into byte 1 using this general form, type of value or type of variable. In this case, this results in no, right? No problem. The value 25 is assigned to the left hand side variable. So further, how the floating point values are assigned to the left hand side one, and the double values are assigned to the left hand side byte variable, right? See this code. Byte b is equal to byte of I. What is I? I is the integer variable, a 325. We are trying to assign the value a 325 to the left hand side byte variable. Second, b is equal to byte of f. F is a floating point quantity. Trying to assign the floating point quantity to a byte variable, and trying to assign the double quantity to the left hand side byte variable. So in this case, the byte int float double are compatible data types both in C++ and Java languages, right? Here in Java, it is said to be a strictly typed language, so you cannot assign the corresponding these types into the lower type value. Higher value cannot be assigned to the lower type. I is an integer one, higher data type cannot be assigned to the least data type B. In this case, we need to perform the typecasting operation. B is equal to byte of I. In this case, what will happen? We are trying to assign B is equal to byte of, what is I? I is 325. But what is the range of byte? Byte ranges from minus 128 to
Plus 127.
Yeah. Totally, how many values are there?
256.
Minus 1.
256.
256. Yeah, 256 integers are there. In this case, just to compare, b is equal to byte of 325, b is equal to byte of 25 here. Since 25 lies in the range minus 128 to plus 127, no problem. There the left hand side variable b assigns a 25. But in this example, since 325 does not lie in the range from minus 128 to plus 127. In this case, the total range of byte is 256. So modulo operation is performed. Modulo, right? What is modulo operation? Over the range of a byte 325 modulus 256. What is the value?
One.
256. Here balance 44, right? 44 plus 25. 60. And is it?
69.
69.
Okay. So performing the modulo operation, that is, you need to find out the remainder after the integer division. So 325 division 256, right? A quotient is 1, remainder is 69. 69 lies in the range of minus 128 to plus 127. So 69 is actually assigned to the left hand side byte variable. This is one kind of typecasting. Another one, have a look into this one. B is equal to byte of F1. In this stage, B is equal to byte of F. What is F? 300.82 F. In this case, what happens? You are trying to assign the floating point quantity to the byte variable. So what happens? First, fractional part will be lost. What happens? Fractional part will be lost. Whatever is 0.82 or 0.02, right? Having the value exceeding 0.5 or less than 0.5, whichever is, total fractional part is lost. This is said to be a truncation. Truncation occurs whenever the higher data type is typecasted to the lower data type. For example, here a floating point is typecasted to the byte variable. So then 300 again cannot lie in the range minus 128 to plus 127. Now what happens means performing the modulus operation 300 modulus 256 44. 44 is assigned to the left hand side byte variable. P takes a range, right? 44.
Excuse me, sir.
P is yes.
Sir, if the value of integer is 1000, sir, then
Value of integer is
if int I is equals to 1000, sir, and if you are converting byte, b is equals to byte of I, then what? Then the remainder will be 744, no, sir. Then it will be out of range of plus 128 to plus 127.
you try to perform the same modulus operation. That expression integer value divided by 256. Find out the remainder and execute that. And if you find any negative values, right? That's what I say. You try to check it and tell me, right? In the next session, I will clear your doubts. Normally, here what you have to do means the numerator is, for example, integer quantity. In case of a float or double, fractional part will be lost. Perform the modulus operation over the range of byte, since the left hand side variable is byte 1, and try to find out the remainder. That the remainder is actually assigned to the left hand side variable. You try to check it for sample values. Suppose I is equal to 500, then I is equal to 1000.
Sir.
Okay, you check it and tell me. Then considering the double
Sir.
type, yeah. Yes.
Sir, can we perform modulo operation 2 times?
Why?
Sir. No, sir. If in rare cases, if the value is not satisfied, if the value is not in the range, can we perform the modulo operation again?
That's what I say, right? For your question, right? I said I have given 2 sample values and test the answer and come with the solution, right? In the next session, I said 2 values. One I is equal to 500. Another one check for I is equal to 1000, or you can take any other integer, right? You try to check out and okay, conclude the output, how or why the output has been occurring like that. Negative values may also come. That's what I am indirectly saying. You try to come with the solution, why or how negative values are coming when performing the modulus operation. So I am leaving this now. Then coming to write the double quantity, double D is equal to 275.92. In this case, double to byte means 0.92 is completely truncated. 275 cannot be assigned to a byte variable. So performing again the modulo 256 operation. So the remainder, right? 275 division 256. The remainder is actually assigned to the left hand side variable. Now check the code. Java Titan version 4. 69, 44, 90. These are the actual results after finding the modulo or modulus operation. Having any queries in this? Type conversion and casting, right? Type conversion this way, casting you need to perform. When the higher type is assigned to the lower type, perform the type costing. Then in case of floating point numbers, say floating point or double are assigned to the left hand side with respect to type casting, truncation will occur. This is important point. Truncation plus type casting. Then the next example. We have seen the automatic type promotion and expressions, narrowing conversions and widening conversions. Now consider this example. Find x is equal to 20, y is equal to 30, z is equal to 50. When we are trying to work with find I is equal to x star y star z, what will happen? First consider this case. Int I is equal to x star y star z. What will be the value of I? $600 by 50.
12.
Right then? Okay,
12.
very good. And yeah, instead of I, right, I try to write same byte variable. Say I am updating in a variable, say byte x or simply x. X is equal to x into y by z. Now what will be the value of x? What will be the value of x?
12.
No, this results in error. First I show the compiled an error. Java C type conversion 5 Java. What is the error message? Incompatible types possible lossy conversion from into to byte. From into to byte. Carefully understand the words from into to byte. So left hand side is int, right hand side is byte. So what is the actual rule means when evaluating the expressions? If you have any byte short character operands which are available in the right hand side, understand clearly. Byte short character operands available in the right hand side, all are type promoted to integer one. This is the first rule in automatic type promotions, right? Evaluating the expressions, right? Automatic type promotion rules. Character, short, byte operands are type promoted to integer one. So of course here x star y slash z, whichever is x plus 1, x plus even 0, x into 1, byte x is equal to 20. Next line you can have x is equal to even x star 1. That is enough. X star 1 means x is a byte 1 is 1, integer 1 is actually integer mode, x is type promoter to integer mode. Say 20 into 1 is evaluated in the integer mode. Integer value 20, whichever is or even x is equal to x plus 0, 20 plus 0. Integer 20 cannot be assigned into the byte variable. So first rule, recall that all byte, short and character operands are type promoter to integer 1. So in this case, this results in a compile time error. To avoid this, you need to perform the type casting. X is equal to byte of, right? How to resolve this means we need to write x is equal to byte of x star y by z is evaluated. So everything should be enclosed in double quotes. X star y by z. In this case, right, we will get a value same to 1. 12 lies in the range of minus 128 to plus 127. Understand? Understand or not? I need to complete a few more programs so that we will be able to complete automatic type promotions. So same example, class type conversion 6. Byte x is equal to 20, short s is 30, character ch is equal to t. I have already coded these examples, sir. If not, if I am typing and explaining, it will take time, so that we will not complete more topics. So that's what I have already worked these examples. I am directly explaining. Hope you understand. Now in this example, see, byte x20, short s30, character ch is equal to d. X plus s plus ch. This is perfectly a valid assignment statement. X is 20, then what is s? S is 30, 30 plus 20, 50, character, right? What is the first
100.
one?
100.
Byte, yeah, yes, 100. Byte short character appearance or type promoter to integer 1. This is the first rule. So D is 100, 100 plus 30 plus 20, right? 150 is actually assigned to the left hand side variable I. Printing the value of I will get a value 150. Now consider this expression. Byte B is equal to 20, short S is 30, character CH is equal to D. B is equal to B. Just now we are discussing all byte short character occurrence or type promoter to integer 1. Now having B is equal to B, what happens? Can we predict it? Can we predict the value of B? Type conversion 7. This will not result in a compile time error. B is equal to B. This is a perfectly valid statement. Type conversion 7. Byte to byte, this is perfectly valid. You can ask, what is actually B here? B is simply a variable, right? And even expression may be a variable or something. Here, specifying only the variable, the value of the variable is simply a byte 1. Range is minus 128 to plus 127. Simply this is assigned to the same variable B. So this case, our rule number 1 will not be applicable. This is very important point. All byte short character operands are type promoter to integer 1. In case if you specify the expression, right? In the expression means you need to consider this way. For example, B is equal to, as we discussed earlier, even B is equal to B plus 0. In this case, what will happen means plus, right, an arithmetic expression, arithmetic operator, 0 is one operand, B is one operand. Ultimately, B is type promoter to integer 1, 0 is type promoter to integer 1, integer plus integer result, integer cannot be held in the left hand side byte variable, so it will result the compile time error. Possible lossy conversion from int to byte. Carefully understand, int right hand side expression is evaluated in the integer mode because the rule is applied, or byte short character or type promoter to integer mode. So that's what is here, right? We mean B is equal to, right, even if you write B star 1 or B star 5, right, what will happen is this results in the compile time error. To avoid this compile time error, what we have to do means we need to properly introduce the casting operation. B is equal to, left hand side is B, so the right hand side expression should be typecasted. B is equal to B star 5 means, parenthesis very important. Byte of B means, as we discussed earlier, again this results in a compile time error because this type conversion byte is only applicable to B, not to the entire expression B star 5. This results in error. To avoid this error, carefully introduce the parentheses. To introduce the parentheses, let me write B is equal to byte of B star 5. No error in this case. Because B star 5, B is 20, 20 into 500. 100 is again converted into a byte value 100. assigned to the left hand side variable b. So no error will be in this case. So when you write the arithmetic expressions, you should be very careful and carefully introduce the typecasting operation. Parenthesis also signifies the important rule. So first rule, right? Hope you understand. Byte short character operands are a type promoted to integer 1. What is the next rule means? All byte short character or type promoter to integer 1. Byte short after that, if one type is integer 1, normally byte plus short results in integer mode. So byte plus short plus int available in the right hand side, that again results in the integer mode. Now byte plus short plus results in the integer mode if one operand is an integer 1 and another operand is a long 1. Say in this case, I is in the integer mode, 5L, this is in a long constant, a long integer constant. Now long plus integer, further result is a long 1. The result is type promoted to long 1. Hope you understand the words. 5L is a long 1, I is an integer 1, integer is type promoted to long. If one operand is long, another one is, for example, integer 1. We are executing the rules in an order, right? So long plus integer results in a long 1. Now, this is one long plus float. If one operand is long and another operand is float, or we can say the sequential order, if any one operand is float, the result is a type promoter to float. Then the sequential order, if any one operand is double, the result is type promoter to double quantity. So we are formulating the rules of automatic type promotion. First rule, what is the first rule? All byte short char operands are type promoter to which type? Integer type. This is rule number 1. Execute the rules in the sequential order. Second one, if any operand is long, then the result is type promoted to which one? Long. This is second rule. Third rule, if any operand is a float, then the result is type promoted to float. Fourth rule, if any operand is double, then the result is type promoted to which one? Double. These are the important type promotion rules. Just consider this example. D is equal to f plus 0.1 means f is a floating point quantity, right? 0.1 is a double one. So one of the operand is double. So the result is type promoter to double. Having f is equal to, right, L plus 0.5 f. L is a long one and f is a floating point one. So try to execute the rules in the sequential order 1, 2, 3, 4. One of the operand is a float one. So type is promoter to float. Float plus double means don't execute the rule number 3 alone. Float plus double. One operand is float. Perfectly okay. Result will not be float because you need to execute the next rule after this rule. Check if any one operand is double. Yes, float plus double. This is a double one. So the result is a type promoter to double one. So whatever the expression, right, in the right hand side, you need to evaluate these rules. Rule number 1, 2, 3, 4. So simply saying whichever is the highest data type, the result is type promoter to the highest data type and assigned to the corresponding left hand side variable. You should have the proper typecasting operations when the left hand side is a lower data type and assuming that there should be a type compatibility between the source and the destination types. So we are concluding the rules of automatic type promotion. First, all bytes or character operands are type promoter to integer one. Then integer plus long results in a long, long plus float results in a float one, then float plus double results in a double quantity. Having any queries? If you have any queries, you can ask. One of your messages, sir, why CH is equal to B? Not possible, sir, because CH character 2 bytes, byte 1 byte. Yeah, you have mentioned reason is also byte is 1 byte. CH is 2 bytes. Character CH is equal to B. So try to check it. B is a byte quantity, right hand side, okay, the least type, and the character is what one? Highest data type, left hand side, perfectly okay. Rule number 1 is satisfied. Left hand side type, right? Two types are compatible, right? Rule number 1, left hand side, yeah, character, highest type, but in the right hand side, what is B byte least type? Rule number 1 is satisfied. Then, what about the next one? You try to check it. Cat CH is equal to some byte quantity. You check and tell me. Okay, with this, let us wind up the session. If you have any other queries, you can ask. Okay, raise your queries through WhatsApp. I will clear your doubts. Thank you very much.
Thank you, sir.